Hello everyone, hope you are doing well. My name is Ashim Roy. I am an assistant professor of Department of Physics at Bhupendranath Mandal University, Madhepura. Today I will talk about wireless power transfer. I think you already heard about wireless charging, which is very popular discussion topic these days. Maybe many of you are using wireless charging technology to charge your mobile phones. Not only mobile phones, many of us also heard about wireless charging to the electric vehicles. There are many companies across the world are working on wireless electric vehicle charging. The electric car company Tesla, founded by Elon Musk, is now top in news in this category. From these two examples, we can realize that wireless charging is one of the fast growing technology in the recent scenario. Naturally, one question came to our mind: how this wireless charging or wireless power transfer technology works? What is the basic principle behind it? Let's try to understand the basic principle of the wireless power transfer. Before going to that, let's see a video clip. This is a simple demonstration of wireless power transfer technology. You can see when the LED along with the coil is brought to the another coil which is connected to the battery power supply, the LED becomes illuminated, and the intensity of the LED increasing when it comes closer to the primary coil which is connected to the battery. So we can see that there is no wired connection between LED and the battery. Still the LED turns on when it comes closer to the primary coil. So the power transfer from the battery to the LED is happened without wire. This technology is called wireless power transfer technology. Now let's go to the basic principle of this technology. Although the wireless power transfer technology is in news from couple of years, the technology is not new to science. The basic principle behind this is electromagnetic induction, which is discovered by Michael Faraday in the year of 1831. He discovered that there is an electromotive force or voltage induced on the conductive loop when the magnetic flux through the loop varies in time. It will be more clear if we see this picture. Here the blue bar is magnet. The blue lines with arrow are the magnetic lines of force which are associated with the magnetic flux. This is a galvanometer connected to the conductive loop or coil. When the magnet moves towards the loop, the magnetic flux through the loop changes with time and a voltage is induced on the coil, and that reflects in the galvanometer reading. When the magnet is at rest, that means magnetic flux through the loop is not changing with time, and as a result no voltage is induced in the loop. The galvanometer reading is 0 in this case. Faraday not only discovered the phenomena, he provided a law to determine induced voltage within the conducting loop. The law states that the induced voltage across the conductive loop is proportional to the rate of change of magnetic flux. The mathematical formula of this law is given by this equation, where E stands for induced voltage, N stands for number of turns in the conductive loop, and del phi del t is the rate of change of magnetic flux. Now, how the magnetic induction plays the role in wireless power transfer? Here is the answer for that. That is inductive coupling. In the year 1894, Nikola Tesla demonstrated wireless power transfer through resonant inductive coupling. He used resonant transmitter to transfer electrical energy from the primary coil to the secondary coil or the receiver by the resonant induction. In the transmitter, the coil is connected to the alternating power supply. Due to the alternating current, a time-varying magnetic flux is produced in the primary coil. Due to this time-varying magnetic flux, an induced voltage is generated in the receiver or the secondary coil, and as a result, lights or voltage is so as a result, lights or fans are turn on. And I hope after this discussion we have learned about the wireless power transfer technology. Now, here is a question for you. Name one electrical component where wireless power transfer technology is used, and the component is being widely used by us from many decades. I think you already guessed the correct name. Yes, that is transformer. That's all for today. Thank you.